Thank you, Dajit. Welcome everybody. First of all, I wanted to ask, who was at Apollo Fest yesterday? For us, coming from Berlin to San Francisco, ending up in a German bar and eating Spätzle and beer was kind of funny. I found some typos in the beer names, though, which is unforgivable. But it was fun. No, it was really fun. Welcome to our talk. Pelumi and me want to talk to you a bit about how we approach server-driven UI at Delivery Hero, and also a journey of how we failed and learned what we don't want to do, and then kind of how we went into federated GraphQL and to the solution we have now, which works much better for us. So my name is Arne. I'm a principal engineer at Delivery Hero, or that basically means I spend most of my day writing Google Docs nowadays. Personally, I refer to myself as the principal GraphQL evangelist in Delivery Hero. And Pelumi is actually my colleague who implemented most of this, and he will go into the nitty-gritty technical details a bit later. So onto the talk and a little bit about the agenda. So just going to introduce Delivery Hero a little bit, because in the US, most people don't know us. Then the challenge or the problem we had that we wanted to solve in the first place. Then this journey of going all into server-driven UI and failing, and taking learnings from that, and then going to the new solution, and that works much better for us based on federated GraphQL that Pelumi will go into detail on. And afterwards, consolidate all the learnings and key takeaways, or things that we want you to take away from this, and in the end open up for questions as well. So who we are. So Delivery Hero was founded in Berlin in 2011. Food delivery and grocery delivery company operating in 70 plus countries. We are market leader in most Asian markets, except China, of course. China has its own version of everything. We have 500,000 restaurants on the platform, billions of orders annually. And Delivery Hero is actually comprised of multiple different brands. So you might have heard of Foodpanda in Asia, Yemek in Turkey, or Foodora in the Nordics, that are basically our biggest brands over there. And they all run on one tech platform, which Pelumi and me are working on, and where this has been implemented. So some context for the talk today as well, just in terms of structure. So as I mentioned, our scale, multi-brand, multi-market, billions of GraphQL queries, one single super graph for all our apps, Android, iOS, and web. By the way, last year we did a talk about our general approach to federation. We're using Golang on the back end. We are using Router 2.0. We designed everything for federation from the beginning, so we didn't have a monograph and we didn't use Gateway. So if you're interested in that, check out that talk from last year as well. And then the goal that we wanted this talk kind of to bring across is kind of how we approach cross-platform UX iteration in a way that frees us from app releases. Because especially in Asian markets, we are 80%, 90% web, mobile and iOS and Android in terms of traffic. So web is really only a bit relevant in Europe still, but it's mostly like most people order food via apps, right? And we were always bound by app releases for many of our changes and experiments, and that was just slowing us down too much. And the solution that we want to show you today, which is kind of more like a concept or a guiding principle, is what we call two distinct layers. So there's a domain layer and a server-driven UI layer in our supergraph, and we will go into the details of that in this talk, but that is kind of the goal that we reached now after failing by going into a different direction. And the result and the implementation of this principle is a specific SDUI subgraph, which Pelumi will talk to you a little bit about in a bit, which returns structured render-ready data to our clients. So the challenge, as I mentioned already, there was a combination of product needs and also engineering pain. So product managers wanted to tweak specific critical design pieces of our applications really quickly and experiment on them, just rearrange certain elements and stuff like that, and doing that without being bound by app releases. And on the clients, we also had the problem of formatting logic being duplicated on all the platforms, so there were inconsistencies between how things looked, and also just a lot of effort on keeping things in sync and so on. So that was kind of the big challenge that we wanted to solve with server-driven UI. And then the first approach, and here it's important to understand that this is pre-GraphQL, so this was all still essentially, from an API perspective, REST-based. But it's kind of important to understand because the learnings are still relevant, even though it's a different technology. So we called this Fluid FMS, which is Fluid Management System, which was a server-driven UI platform that the vision was to be able to launch completely new screens in a couple of weeks in a couple of days in a country that previously didn't have them at all. And it was completely backend driven, configuration driven, and helped us then to decouple app releases or our updates from app releases. And basically the clients were essentially just dump rendering machines that would get the configuration and template and the data from the backend and just render it. And obviously benefits of faster time to market, easier experiments, and reusability of components across screens. This is how that looked in the way that even a product manager could go into the configuration of a certain screen and change things down to the level of padding, text color, font sizes, and all of that. And then in real time, you would basically see the changes in the app. And all of that sounds pretty awesome, right? That's also what we thought initially. But here's why it didn't work for us. So in the end, it was too heavy. It was still a good detour with good learnings, but we learned that collapsing everything into one layer, like data, UI logic, and configuration, was too complex. And it was all blended together, and we required heavy SDKs that had to support all of the components, and there was also quite a high adoption burden, because it turns out engineers don't really want to spend a lot of time onboarding onto a technology that they can't use anywhere else outside of your company. And especially if it's like a complex DSL framework with multiple components, essentially it was a whole ecosystem. And that's also where GraphQL came in to really help, because that's a mature standard that is used across the industry. There's a lot of documentation around it. And in the end, one of the biggest problems was cultural in that sense. Like adoption was the problem, even to the point where client engineers were thinking, why do you even need me anymore if you have this, right? And kind of being concerned about that. And in a big company with hundreds of engineers, that was a real challenge. And in the end, also, there was this high dependency on the SDK teams, because whenever a team wanted to support a new component that wasn't there before, or some interactivity, specific animation, stuff like that, they had to wait on the SDK team to kind of support these components and so on. So in the end, Fluid taught us what we didn't want, which is a too generic SDUI DSL with a high SDK tags. We figured we were essentially recreating HTML in a way. But our lesson from it wasn't that server-driven UI is bad. The lesson was just that we needed a different approach, and that is where we approached the new solution in federated GraphQL, and we wanted to keep our domain data layer separate from the UI layer so that they can still be used separately as well. So the principle, again, that you will see throughout this talk, and which is the main thing we want to communicate, because the solution that we have is one way to do it, but it's more about the concept here is a 2 layers, 1 graph approach. So we have our domain layer, which is a bunch of subgraphs that provide all of the canonical data, the business logic for our restaurants, products, discounts, orders, customers, all of that. And clients can still request that on their own if they want the raw data and don't bother with any server-driven UI stuff. But then we have a layer of subgraphs that is in the UI layer, which just defines UI-specific types that return render-ready data. And the key point here is that only the UI layer depends on the domain layer via the requires directive. So the router composes everything. The UI layer or the subgraph doesn't have any internal dependencies to other services. It gets all its input data from the domain layer subgraphs via the requires directives and then just formats it, basically. So the business logic is strictly only on the domain layer, and the UI layer just describes how the UI should look like. And the router is a composer in the end. So that way we can also make changes to domain logic without breaking the UI and vice versa. And yeah, this principle kind of underpins everything that we want to show you today. And in terms of one implementation on how to do this, I will hand it over to my colleague Pelumi to tell you all about it.
Okay. Hi. Hi, everyone. My name is Pelumi Olaoye, and thank you, Anne. I will just be diving deep a little bit into how we've achieved the server-driven UI for delivery era. One of the things also that we really didn't do well before was that we were trying to combine both the domain layer and the UI layer into a single solution, and that later became pain for us. So the principle Annie just mentioned, of course, is having separate UI layer and also separate domain layer. The GIF, the GIF you see in the middle, is one of the restaurant's listing pages of one of our brands. And as you look at the items there, one of the things we did wrongly before was we were trying to control everything on the page, even things that actually didn't need to be controlled, right? So we wanted to keep the same benefits that we had before with Fluid, which is increased time to market and, of course, fewer app releases, and also not nuke the disadvantages that we had before. So we had to laser focus on what are the things that actually changes frequently on the UI, what are the things that get modified frequently on the UI that warrants this app releases. And we narrowed it down to what I would call a component. So on this screen, you would see multiple items getting scrolled by, but each item, I want you to think of it as a component. And as you see also, these components can take different forms, right? So you could see some are larger, some are smaller, some are extra small, and the likes like that. And it just varies across the screen. So we decided to then focus the flexibility of the component on just those components in the terms of SDUI. And now when I want to also try to rephrase that component in your mind to call it tiles. Now, tiles is a representation of a restaurant, which would be a vendor, or the product that belongs to that restaurant on our brand. So as we go on from here, whenever I say tile, think of the image that you see on the left-hand side. Right, let's go on. So this is heavily powered. It's fully server-driven UI, and the idea behind this is business frequently experimented needs on the look and feel of the layout of the tile needs to be highly configurable, such that if I want to make any changes, I don't need engineering resource. We actually had one project that we wanted to change how the tiles looks like across our screens, from the restaurant listing to the restaurant details to the cart to the checkout, and that took us 3 months. And why? Because there are separate teams owning these pages, and you need to align with all of them. You need to write an RFC, you need to do all of that. And that was just very painstaking. But the same thing can now happen with this server-driven UI approach in just a week, right? That's where we want to be, right? And like I said, this is highly configuration-driven. An important thing is it's reusable across the screen, right? So I only need to just define it. And this also helps us with the context of parity, right? Because different teams are owning it. One team could make some form of mistake in how they compute the tile, and that just means you get a different experience of the tile across the screen, which is not where we want to be. So this is highly reusable across our screen. An important thing also is one of the things Hani mentioned earlier is we have some sort of stable schema grammar. in the sense that it's a GraphQL, every tile is a GraphQL object type, right? And it's stable, and we can also evolve the tile in a predictive way, because that is highly tied to our internal design system that is supposed to then help to link together with the render-ready data. Again, yeah, integrated with our design system. And interesting thing about this is you don't have to make a choice. You're not constrained to just the render-ready data or the domain data. You can still request for both in any way you want. And also for the team, a team can come and say, I still need the domain data. I don't care about your server-driven render-ready data. Or a team can say, I don't need the domain data, I need this one. So it's still possible to do that. But let's dive in a little bit deeper into what's the content, actually. I said earlier that it's highly configurable. So the first thing we did is we tried to categorize the items on a tile, right? In some sense, there's a section of it that is just the incentive that applies to a vendor, right? If you spend more up to this, you get this discount. If you spend more than this, you get this discount. And there's this voucher that applies for you. There's that category. There's another category that's supposed to be just the basic information of the vendor, the name, the delivery information, and the likes like that. There's also the media section. And I said earlier that this is highly configurable. And the flexibility of configuration is also narrowed down to each of these 4 categories and each of the items within these 4 categories. So you can make changes anywhere. You can make changes on visibility. You can make changes on positioning. You can make changes on styling. Right? Initially, we were doing a lot of things with fonts, colors, and all of that. But that now is in our design system that links up with this render-ready data and knows what to do per time. So any project manager, engineering manager can literally just come to this configuration, make the changes, and then it reflects across the pages of the apps. Great. Now, Apollo Supergraph or Apollo Superglue. Because actually it's some form of glue as a service, I would call it, as opposed to the previous way of having things internally woven in each other just to be able to have access to some other data. And this is supposed to be a joke, so if you didn't get the joke, I probably did a terrible job with this. Okay. So as a customer, if I pick one of our apps and I want to see the list of vendors in my location, let's see how it happens behind the scene. So if I come as a client, of course a client app, and I send a request to the router to say, hey, fetch me the vendors in this particular location, what happens under the hood? The router goes to the domain layer subgraph that owns the business logic of getting the vendors in that particular location. But the interesting bit of it is it doesn't get all the data of each vendor. It only gets the code of the vendor. But in that case, if the router only gets a list of code, it doesn't make sense to me as a customer if I want to place an order. Because in the real sense of things, the things that make sense to me for a vendor is the name, the delivery information, the incentive that applies to the vendor, the cuisine information, the budget information to know whether I can afford that vendor or not. But I don't have all of that. The router doesn't have it. It's just a list of code. So what happens? And this is where the SDUI subgraph comes in. If the tile field, which is supposed to be the SDUI field, is requested for, what the router does, it goes to the SDUI subgraph that you see here, and it tries to say, hey, for this vendor, give me a tile representation of what this is supposed to look like on the UI. But then the SDUI subgraph says, hey, guy, I don't have this because you've not given me the data I need. And this is where the requires directive comes in. Think of it as a way to specify I have these dependencies to be able to do my job. And that's essentially the requires directive. And what it does is it tells the router, give me this data, this data, this data, then I will give you what you're asking of me. And at that point in time, what the router then does, I've tried to put some color coding, some legends across the data inside of the vendor to show you which of the domain layer subgraph owns the data. And then the router goes to each of the subgraphs, gets the data, and then passes it to the SDUI subgraph with the help of the requires directives. And that just gives me the render ready state, fully structured, of the vendor. The client doesn't need to do any manipulation on all of the vendor, and we'll get to it later how this happens on the HDUI subgraph. Now, as a client engineer, mobile engineer, I don't know, maybe we have some Android or some iOS or some web engineer in the room. I don't really care about everything that I've said before. I care about, okay, how do I use this, right? And all you need to do as a client engineer is, of course, your query, and at any point in time where you have the vendor data, just put the tiles inside of it. And at that point, you don't need to request for anything else. What happens here is the router then picks your tiles and goes to the SDUI subgraph at every point where it needs to display a vendor, right? And we said earlier also that this is, we have some form of stable schema grammar, so there's a definition inside of the tile that helps us. I'll just explain that in a bit. So I mentioned earlier that we categorized this into 4 bits, from the media to the vendor basic information, the name, the location, the delivery information, to the primary tags. In this context, I haven't said anything about primary tags, so I'll try to explain it now, which would just be the incentive that applies to the vendor, and the secondary tag could be any other thing outside of that scope. So each of the category is just the list of what we call element group. And why did we call it element group? It's supposed to be a generic graph object that could hold anything that's possible to be shown in a tile. So it could be an image, it could be a text, it could be an icon, it could even be a separator, it could be a vertical or horizontal separator. And this is essentially how the schema looks like for the client. Now, on the HDUI subgraph, let's see how it looks like. I went too fast. One slide, please. Great, thank you. On the HDUI subgraph, this is how it looks like if I want to define it. So I've tried to narrow down your attention to just the black bit. And this is the tile field, but then you see the annotation of the requires directive also that then tells the router, hey, to do my job, I need the availability data of this vendor. I need the image of this vendor and every other thing that belongs to this vendor. And that's the point that the router then goes back. And don't even worry about the round trips that is happening here. It's pretty fast, thanks to Apollo. Actually, to resolve just one vendor is something around 40 milliseconds, and that's also batch, so it even gave us a little bit more performance on the query level. Right, and moving on. Now I have said all of this, I'm sure you're interested in seeing how a fully render-ready data looks like. Right, let's go. So in a very miniaturized way, you see it's only just 4 fields. Ignore the first one. It's just informing the clients that this could either be large or small tile or extra small, the form of the tile. But you see the last 4, which is the media, the primary tags, like I said earlier, the vendor info, and every other thing like that. And I'll just try to show you the media is essentially just an internal link, image link. And then the vendor info is just a list of each of these things that needs to be displayed as vendor information. And the same as primary tags, and it just goes on and on like that. And one interesting thing also is I mentioned earlier that there is some form of styling. So you see it's possible to keep things highlighted, or keep it bold, or keep it striked out, you know, and even on an icon level, you can decide to highlight your icon or anything like that. And having gone this approach, aside from just keeping the advantages that we had with Fluid, which is faster time to market, lesser app release cycle when you need to modify your UI layout, we've also witnessed high performance, because before, clients would have to request for like 80 fields, perform the computation before they are now able to render. But now they only need these 4 fields that is just an array of what they just need to run through and just display connected to the design system. And of course, that has also helped us with the time to render. We've had some gains also on that, approximately 100 milliseconds on that. And the interesting bit for us, it was designed for this and we were able to achieve it, was to be able to control and reuse the tile across screens, right? In the sense that you don't need to then reach out to these multiple things to make changes to something that looks exactly the same across all the screens, right? Doesn't really make any sense. And also we've tried to keep it as flexible as possible. And there are times when PMs and EMs would just come and say, hey guys, we want to make this change. I will just tell them, yeah, this is the configuration, go make the change. Right. And at this point, I'll give it back to Annie, and he will explain where we want to take this from here, because we still have a couple of improvements we want to do on this. Thank you.
Yeah, thank you, Pelumi. Yeah, that was a deep dive into the technical implementation of things. And I want to tell you a little bit of where we are right now, what we can still improve, and where we want to go. First of all, we have now figured out this is the right direction for us, because it allows us the right balance of being able to iterate on the UX quickly, but still being not really blocked by any big SDK changes and stuff like that. So with that, there are still some challenges, right? Every new approach still brings some things that can always be improved, and it's the same for us. And we want to be transparent and share these as well. So one of that is we can always improve schema hygiene, right? So there's, even though we have these guidelines and strongly typed UI elements, entropy always creeps in. So sometimes teams use magic ints, free-form text, nullable fields where they shouldn't be nullable, and so on. And this is just a reminder that schema hygiene is a constant investment and not a one-time cleanup. So a good schema governance, a group of people that kind of has the governance top of mind is really beneficial there. Then another thing that is important is UI state degradation, which we do to some extent, but this could still be improved. For example, in the case of the vendor tile, if one of the dependencies is unavailable or slow, you want to be able to fall back to a state that is a defined state, that is in the best case even aligned with your product and your design team, to say this is our degraded UI state for this tile, and it's not some broken piece of UI across the apps that doesn't look right. Because it's also part of the custom experience, things like that happen, so you have to be able to degrade gracefully in different ways. And to that extent, it's also now possible to observe that, which we are not really doing to that extent yet as well, but we want to. Because now you have the ability to even not only have golden signals about performance of your resolvers and so on in the observability, but you can even have UX correctness as part of your observability. So you can actually track how many customers saw this degraded state of the tile that previously was not really possible. And then you can also make changes based on that, or decisions based on that. Another thing is requires overuse. So requires is very powerful because it allows you to pull in data from all other subgraphs. But that also means that the router has to make all these calls. And in some cases where we use a tile across different use cases, developers tend to just put into everything into the requires directive just in case, so they can use it for all kinds of use cases. But there is a balance between having a specific resolver for a specific use case that only requires whatever it needs, and having one that is very flexible and usable everywhere. So we are happy with the performance, but we still spend some time looking at query plans, figuring out what subgraphs have maybe not implemented data loaders properly, and then that can lead to performance problems and so on. So there's a bit of that is also kind of something that is a bit tricky to get right. But eventually, the router is really high performance and is a great composer for these kind of use cases. And generally, if you follow the best practices around data loaders and so on, this is less of a problem. So lastly, the key principles, again, that we want you to take away from this, where Pelumi showed one implementation of these, is again the 2 layers, 1 graph approach, where we split the supergraph into the domain layer that owns the canonical facts and the UI layer that describes how to present them. So that keeps the responsibilities clear and avoids mixing business logic with logic and business logic with representation. And the important fact there is that the SD UI layer only describes, it does not compute. The domain is a layer that computes everything. So this means even though, for example, as Pelumi showed, there can be instructions like that text is highlighted, but we don't go down to the level of text color, text size, stuff like that. So the UI layer is very thin in just describing, giving hints to the clients on how to render stuff based on the design system, but they still control that on the client side. It's not like a fully featured server-side rendering as Fluid was more in that sense. Then it's important to have a strongly typed stable grammar. So you want to have want to have clear enums, translation keys, value hints, no magic strings, no freeform text, stuff like that. So clearly typed UI elements in your schema that the clients can use to do code generation, code completion, all that kind of stuff. And from there, it's also then easy to evolve the schema predictably, because instead of changing a UI type in place, we would recommend to create a new version of a type so that you don't break existing implementations on clients, but make a new version of a UI type that then the clients can gradually adopt. And as you roll out new client releases, they would then be able to, you are then able to roll out that new UI type without breaking existing implementations. And obviously, this also makes it really easy for the clients to know what they get. They know, with a stable grammar, they know what to expect when they get certain types. And lastly, like I mentioned before, design for graceful degradation. So every component should render something if the upstream services might be slow or missing. And we do that by including median values for some information. Default icons could be one way to do it, or reduced copy text is another way. But again, aligning that with your product and design teams and having a defined state for a degraded experience is kind of important. Yeah, and that is the core of it. At the QR code, you will find our guidelines, a copy of it. That is a Google Doc where you can also comment on, where it's a bit more detailed on the do's and don'ts on this approach and the basic principles. And it's also important to understand that we give our teams just these guidelines. We don't want to enforce a specific grammar on all our teams, because that is also super hard across a large company to make one size fits all kind of approach. So that's why we opted for giving teams a couple of guidelines that they can then build their own stable grammar on and do server-driven UI. All right, that's it. I think we have still a bit of time for questions if you have any. Otherwise, of course, you can come to us afterwards and have a chat. Thank you. One cup? Questions? Yeah.
Sorry, I got it first. Hey, yeah, thanks so much for that QR code as well. I think that is very valuable. So I just wanted to shout out that. My question is related to localization. You guys support a lot of different countries and language features, and then it sounds like you guys have, two things that control different sort of responsibilities. So I just wanted to get some thoughts on how you guys approach localization, like type-wise or domain data-wise, anything you want to, or any challenges you had with that.
You want to take that?
Yep.
Yeah.
Hi. Hello. Hi. Can you hear me? Yes. Okay. So for the text, especially for, I showed a section that had element group and could either be a text or icon. So for the text, we actually have an internally aligned translation key, and that on the client also is linked with like a translation system that actually then translates the text. Sometimes, for example, I give a quick example to narrow it down to your context. If I want to display, say, I don't know, maybe an incentive that says if you spend this amount, you get this amount free. That's actually a text and a number. On the tiles, it's going to be a text. It would send you the translation key and also send you these 2 arguments that needs to be interpolated on the translation engine. So that is done automatically on the client app, so the localization is handled that way. Yeah. Does it answer your question?
Thank you.
Awesome.
Yeah, over there.
Hi, thanks for the wonderful talk. I have 2 questions. So the first question is, did you have a problem with this kind of server-driven schema building? Like the schema gets like much more complex, and like the grammar is like too complex for when like backend teams are basically designing features. Like the schema gets like just too complex to read and understand. And like, did you have that problem or did you not? Like, and how did you solve it if you had? That's my first question. And then the second question is like, when building these like kind of server-driven schema things, like did you have kind of maybe slowness introduced to build like SDKs on the front end kind of devices as well, like iOS, Android, like to basically build SDKs to interpret this complex schema?
Okay, good questions actually. The first one, no, the schema didn't become complex because the query now became fragments defined on the client bit. And you don't, everywhere you have the vendor, you don't need to redefine the fragment there. You just need to slot in just the name definition of the fragment and not redefine everything. Because of course, we're also thinking on things like the maximum query height, just to ensure also that we don't have a really large query to deal with to help the router also with performance issues. The second question, I'm trying to remember that now. Can you say it again?
Yeah, I can say it. So like when you interpret this server-driven schema on the devices like iOS or platforms.
Oh, the SDK question.
Yeah.
Okay, so no, now we no longer use SDKs. That was one of the things that we had in Fluid, as Annie mentioned. And now it's just supposed to return a list of these things to you. And what the client does is run through this list and just map it to the design system. So there's no SDK in between that anymore.
Okay,
Yeah.
thank you.
I just want to add to your first question regarding the schema design. So it's definitely still sometimes a challenge also to keep these principles, like, because teams always try to, or sometimes try to still make it more server-driven in the way that they still can control font sizes, or that creeps in sometimes, and we have to then kind of, the strong governance is still kind of a lot of effort in that sense. So you just have to have these kind of conversations and make sure that people really understand the idea behind it, and otherwise it could over time kind of drift into a kind of mix of approach, or that in some cases the logic and UI gets mixed a little bit. So that's without governance, I think it's very hard to keep the schema clean still.
Can you talk a little bit about local development for like the SD UI subgraph? Did you find like as you're adding requires to all of these domain subgraphs that local development became cumbersome, or are you able to just use like Rover and were engineers on board with, you know, kind of all of the dependencies that server-driven UI subgraph would have? Did you build any tooling or anything like that?
Oh, yeah, I can take it. Interesting bit actually, like Hani was mentioning, one of the problems we currently have is an overuse of the requires directive, right? So where for even cases where you want to show the basic form of the tile, which would be the extra small, you only need to show the name of the vendor and just the delivery time. It's still, the case is still that all the required data are still being requested for. And in that case, they are actually not needed. So it actually makes it look like an overkill, and the direction we're trying to gear towards is also, it's sort of like some trade-off with reusability, but also separates the context for each tile type. So for the small type, there's a predefined data that it needs to fetch, and it doesn't need to do more than that. For the large type, it fetches as much as it needs to fetch. So there's that complexity that we're still looking to solve, which is why I said this is not like the final solution. We're still looking to improve on that.
Yeah, to your question on like local development, that is definitely a challenge. Like right now we mock the subgraphs locally, so you can spin up your own mocked supergraph which works for most of the simple data cases, doesn't work for every case. Sometimes we actually have to go to a staging environment or something. It's not perfect, but yeah, that's kind of the way we do it right now.
Thank you.
Hi, thanks for the talk. How do you configure the metadata? Like, is it hard coded in the server side, or is it some kind of like database that backs it? Just curious.
When you mean the metadata, you mean the
Like the tile
configuration?
definitions and things like that. Yeah.
Okay. So right now it's some sort of JSON configuration actually that is synced with S3, and there's an internal cache, a pod level cache, and also an external cache that sort of like helps to sync that. And it takes roughly like 5 minutes from when you make the change to when it actually reflects on the hub. Yeah.
Thank you.
Yes, okay.
Hi. One question. What kind of lessons learned do you have around testing and automation within the SUI layer side of things, like from a front-end perspective? Do you just focus on like just passing through a bunch of lorem ipsum to kind of like stress the templates themselves? Do you do anything further as far as like what you add to your automation testing process?
I mean, in terms of performance testing, so on the SDUI subgraph layer, we run regular load tests on that for the specific tiles that the clients, for the queries that the clients implement to make sure that the performance is there. And then on the mobile side, we have our end-to-end test suites that just check the general rendering correctness and stuff like that, which can also still be better in terms of degradation and kind of testing that properly as well. But yeah, so on the backend layer, we have the load testing mostly, and then on the UI correctness is then tested via end-to-end tests on the clients.
Okay. Thank you.
Okay. More question here?
So I have one more question around, so you showed, I think, how you use requires and basically try to separate the domain layer from the UI layer. The query, you showed some sample queries as well. Looking at the sample query, it seemed to me like the client needs to know what data is needed for the tile to render, and then has to ask for the data pieces, attributes, as well as then like have a tile component to ask for the SDUI representation. So the client essentially needs to know what data points would I require for my tile to render. That is one approach. The other approach I've seen across as well is where you just rely on the SDUI layer to fetch the data behind the scenes automatically and just give it back. The client doesn't really know what data points are used to render the tile. Like, did you have this sort of comparison, or like why did you go with this approach where the client has to ask for the data points as well as the tile?
It actually doesn't. Maybe it's a bit confusing in the slide because we wanted to show this is the data that the clients actually need to show the relevant information to the customer, but it's not actually requested in the client. They just request the tile field and the list of elements, and then everything else comes in via requires.
Okay.
If I can add to that, the reason of given the flexibility of also being able to request for the domain is some other team that doesn't want to use the SDUI layers who can still come and say, I'm not going to use it, I want to use this. But if you decide to use it, you don't need the domain data to render the tile. Yeah.
Thank you very much for coming. Thank you.